Hi there guys, so this is the second video on recurrence formulas or recurrence relationships, but these are tricky. Now you'll see in a minute why these are tricky, and it should be quite clear to you that when you need to use this this formula here, -1 to the power of n. So let's get you working for a minute. I want you to pause this video and take a couple of minutes, see if you can work out the rule going between these terms. They're not that easy to see, so you're going to have to give it maybe 2 or 3 minutes to do, but it's going to really help you understand this video if you do it. Okay, I'm going to assume you've done that now. So the first one, you should have got this. So it's going up in 4, then it's going down in 7, then it's going up in 10, then it's going down in 13. So you can see this is a problem. So how do we write this? So you can see the sign is changing each time. And when you have the sign changing each time, I want you to think about this. So let's start this pattern. So we're going to have u n plus 1 equals. So my previous term, I'm adding 4. And then I'm taking away 7 from the next term. So I'm not actually doing anything. I'm not doubling or tripling this number. So there we go. So it's the next term is my previous term, but I'm adding 4. And then I'm taking away 7, then I'm adding 10. So you should be able to see, just ignoring the signs, just looking at these numbers, you should be able to see and apply some mathematical knowledge. And hopefully you can see this. It is the same as 3n plus 1. They're going up in 3s. What else goes up in 3s? Your 3 times table. They're not your 3 times table, because that would be 3, 6, 9, 12. This is 3n plus 1. So now we've just got to worry about the sign swapping, and this is where this comes into play. Now you can see the first one, I have just drawn this orange line through it, but it's a plus. It's plus 4. So what I'm going to put in is this. So -1 to the n. Now think about your negative knowledge. If you want to make it a plus, what sign am I going to put here? So a plus and a minus make a plus, or does a minus and a minus make a plus? Well, there you go, a minus and a minus. Now the numbers are 3n plus 1, and we've got to state the first term. So u1 is 1. So just let me prove to you why this works. So if we take u2, so when n is equal to 1, so u2 is u1 minus, remember n is 1, so we're going to put it to this, and that's 3n plus 1 is 4, when n is 1. Okay, so we've got subtraction, we've got indices, we've got multiplication. So everything follows BIDMAS, remember, so we've got to do this bit first. So indices first. So -1 to the power of 1, well that's -1. -1 times 4 is -4. Oh, and I'm sorry, u1 is 1 there. So we've got, the second term should be 1 minus 4. So 1 minus -4 is +4, which is 5. And that's exactly what we have. I'm going to show you another one of these, because the first time you see it, you should be getting a little bit confused. So you could even pause this next one and try it out for yourself. Okay, so here you should have had -5 plus 7 minus 9 plus 11. So let's go ahead and start writing this. So un plus 1 is going to be my previous term. So I'm just going to get rid of that. So my previous term, so un. Again, I'm not doing anything to it like doubling or tripling, so I'm just going to leave it like that. And now I'm taking away. So because the signs are swapping, I know this is going to be involved. So I'll just try and make that a bit more. Oh, that's horrendous. So I try and make that a bit curlier. There we go. So I know it's going to have that. Now, my first term here is subtraction. So I've got to make this a subtraction. So that has to be a plus, because a plus and a minus makes a minus. Now, looking at these numbers 5, 7, 9 and 11, you should be able to tell me that they're going up in 2s. It's not the 2 times table, it's 2n plus 1, where u1 is equal to 5. And there you have it. Test it, follow BIDMAS, whatever you need to do to make sure you understand it, but that's it. Okay, so the next two were slightly different. Here you should have seen, it's much harder to spot, but it's tripling and adding 2, tripling and taking away 2, tripling and adding 2. Then the next one will be tripling and take away 2. So how do we do this one? Because this is different. So let's start the same way. So our next term along, but this time I am doing some multiplication. So, and you can see every single time it's the same thing. So it's actually 3 lots of the previous term. So the signs are swapping, so I know I'm going to have this. Oh, that's horrendous. So my computer doesn't like this software very much, so you have to bear with me at the moment. We know we're going to have this. Now, these numbers, well, that's not going up. That's just a constant 2. So I'm not going to be putting any nth terms here. In fact, you could put just a 2 there because that's all it is. It's just a constant 2. But I think it looks better there. Because remember the nth term on here, it is just being times by that. So whether you put it at the front or the back is completely up to you. You could put the nth term here if you wanted to at the front. I just prefer that at the back. When it's a constant term, I prefer that at the front. Okay, so the first one we need to do is a plus. So we've got a minus. So how can we make that a plus? Well, that's a minus there. And there you have it. So where u1 is equal to 1. One more of these. So times 2 taking away 5, times 2 adding 5. So as soon as you see this plus and minus swapping, you know it's this. Every time we're doubling the previous term. So un plus 1 is double the previous term. Now this 5, it's not an nth term, it's a constant 5. So I know it's going to be 5 lots of my minus 1 to the n. Again, you can put the 5 there, but it's easier and nicer to put it here. The first one is a subtraction. So how do we make a subtraction? What sign do we put here? Well, that's going to be a plus, because a plus and a minus makes a minus. And we need to say the first term, otherwise it could mean anything. There it is. So ask your teacher for some more of these if you haven't got any, but they're definitely worth the practice. All right.